Today we're going to do a review with sections 3.4 through 3.6. So I would like you to pause the video and draw a segment and mark up either the congruent parts and or the right angles based off of the given information. Okay, so hopefully you pause the video and now you have your sketches. So let's take a look. So when we're talking a median, remember a median is going to go from a vertex to a midpoint on the opposite side. Since it's saying that it's a median from C, C is the vertex, which means the opposite side is the segment AB. So that means that there's a midpoint, let's call it D, that I just then need to connect C to D. And then to show that it's a midpoint, I know that I need to mark it with two congruent segments. So there's my median from C. In number 2, I want a perpendicular bisector from the segment FE. So the fact that we're talking about two vocab words here, perpendicular and bisector. So start with the fact that it's a bisector of a segment. So the segment FE is being bisected. So that means that there's a point in the middle. You can call it whatever point you want, but I know that it's bisecting it, so it's dividing it into two congruent pieces. If I also have something perpendicular to that segment FE, that means that I need to create my segment where there's right angles, and notice that this segment is not going to go anywhere near that other vertex of D. So here's my perpendicular bisector. Number 3, it's asking for an angle bisector of Q. So if angle Q is being bisected, I know that I want to draw, a segment, or you can even draw a ray, but it's going to then be dividing that angle Q into two smaller congruent angles. And then finally, in this last one, if we're talking an altitude goes from a vertex and is perpendicular to the opposite side. So the segment is JL. That's where the right angle that's perpendicular is going to be. That means that the angle that's opposite is K. So I'm starting at K, and I essentially want to drop a segment that will then be perpendicular. Notice that I'm not going to the middle of the segment, because then that wouldn't form a nice looking T. Remember, anytime I'm doing perpendicular, it needs to look like the letter T, so then I know that I have my right angles. So there's all of my segments and the marks of those segments. All right, let's take a look at this. It says the perimeter of the triangle BAD is 65. AG is 18. So let's do this. I'm just going to sketch a picture of a triangle. I don't really care what the picture looks like. I just need 3 sides. I'm going to label it BAD. I'm going to start marking out my picture. So BAG, so AG is 18. I know that AB is 2x plus 7, and BG is 3x plus 5. So there are my 3 sides. If I'm giving you the perimeter means that I want to add up all the sides and set it equal to that amount. So 2x plus 7 plus 3x plus 5 plus 18 has to equal 65. So I'm going to start combining like terms. 2x and 3x gives us 5x. If I add 7, 5, and 18 together, that's going to give us 30. This still equals 65. I'm going to subtract 30 from both sides. That gives me 5x to equal 35. I'll divide both sides by 5, and so x is 7. So it says solving for x. Now we want to determine whether this triangle is scalene, isosceles, or equilateral. We have to understand that those are dealing with the lengths of the sides. So I need to go back and determine what is the length of each side. I already know that AG is 18. I just have to plug 7 into the segment BA and BG to figure out those lengths. So to find BA, I'm going to do 2 times 7, and I'm going to add 7. Well, 2 times 7 is 14, and 14 plus 7 tells me that this length is 21. Then I'm going to plug 7 into this 3x plus 5. So 3 times 7 plus 5. Well, 3 times 7 is 21. When I add 5, I'm going to get 26. So if I have a length of 21, 26, and 18, none of those sides are congruent. And so if I have a triangle with no two sides congruent, that is going to make it a scalene triangle. So scalene triangle is my answer, but then it also says justify with a written explanation. So because no two sides are congruent, the triangle is scalene. All right, let's take a look at this. It says the segment AC is a median in the triangle ABD. So the big triangle ABD contains a median. Remember, a median starts at a vertex and goes to the midpoint on the opposite side. So if I'm looking at AC, C is that midpoint on the segment DB. So that means because DC is already marked with one tick mark, I get to mark CB with one tick mark as well. They're asking us to find the length of BC. Well, how am I going to find that length? Given this diagram, I see that I have two expressions and I have the same markings next to each of those expressions. That means that the segment AD and DC are congruent. Congruent means equal. So I get to set those two equal to each other and I can start solving. So I'm going to subtract the x. I'm going to get 14 to equal 2x plus 4. I'll subtract 4. I'll get 10 to equal 2x. Divide both sides by 2, so I get x to be 5. So now that I know that AC is the median, and so CB is congruent to DC, I can plug 5 into that expression for DC, and that will give me my answer for BC. So I'm going to take 3 times 5 plus 4. 3 times 5 is 15. 15 plus 4 tells us that those are a length of 19. All right, let's take a look at a proof. I am going to start with my first given. So the segment SM is congruent to the segment PM. That's given information, and I'm going to mark it in my picture. So SM gets one tick mark, PM gets one tick mark. All right, can't expand on that, so I'm going to move on to my next given. The segment SW is congruent to the segment PW. That is also given information. SW is down here, so I'm giving that 2 tick marks. PW also gets 2 tick marks. All right, we want to try to prove that angle S is congruent to angle P. Now, in this problem, I only see one triangle. I see the triangle SMP. But I want to try to prove congruent triangles so I can then eventually get to what I'm trying to conclude. Notice that I can create two triangles by creating an auxiliary line. So notice that my statement is that I want to draw the segment MW, and that's because 2 points determine a line. So by connecting point M and W together, it's now created two smaller triangles within the triangle SMP. And by having that, now I can see that those two smaller triangles share a side. So MW is congruent to MW, and this is because of the reflexive property. Now that I see my two smaller triangles each have 3 markings, I can prove that the triangle SMW is congruent to the triangle of PMW. And if you look at the markings, that's because of side, side, side. So notice that step number 1 is a set of congruent sides in the small triangles. So is step number 2 and step number 4. And now that I have congruent triangles, I can prove what I'm asked, that angle S is congruent to angle P And remember, anything can be congruent inside congruent triangles because corresponding parts of congruent triangles are congruent. CPCTC. Corresponding parts of congruent triangles are congruent. Let's look at another one. I'm going to write down my first given that the segment FD is a median. That is a vocab word that we need to expand on. So while I can't mark anything in my picture right now, we have to know what a median is. Remember, a median starts at a vertex and goes to the midpoint on the opposite side. So notice that between F and D, F is where the angle of my triangle is, and D is going to then be the midpoint. So that means that if D is the midpoint, segment CD has to be congruent to segment ED. And that's because if a segment is a median, because that was what was given to us, then it divides a segment into two congruent segments. And then I can mark that in my picture. So if I have a median, I'm expanding on it. If a segment is a median, then it divides a segment into two congruent segments. I can't expand on that any further, so I'm going to move on to my other given that the segment FC is congruent to the segment FE. I can mark that in my picture. I'm going to give it 2 tick marks. I can't state anything else as far as I don't have any other givens, but if we're looking at the picture, I see 2 smaller triangles that share a side. So segment FD is congruent to segment FD because of the reflexive property. Now, hopefully we notice that in my markings, I've got 3 things in each of those triangles. So I can say that the triangle CFD is congruent to the triangle EFD, and that's because of side, side, side. So it's not because of step 1, because that doesn't state congruent, but it's steps 2, 3, and 4 where my congruent segments were with my triangle. And now that I have congruent triangles, that means that any of the other pieces are congruent. So I can go to my conclusion. I can say that the angle CFD is congruent to the angle EFD. And remember, that's because corresponding parts of congruent triangles are congruent, or CPCTC. Corresponding parts of congruent triangles are congruent. All right, so that's us doing our